Hi, this is my video number 36. Yeah. And in this video I'll talk on volume integral. Volume integral. Okay, now what does volume integral? This is basically triple integral over the region D. Yeah, triple integral over the region D, where for a function of x, y, z over the value. Okay, now if you look at the I'll try to describe this. What is the triple? What is the volume integral? If you consider, let's say, a closed region, closed bounded region here, yeah, closed bounded region, whatever the shape is give a volume. All right. So let's say this is our region D, where D is bounded closed region, and we define as a function of f, where f a function of x, y, z. Okay, and if you take a small volume here, let's say we have this small volume over here, that okay, that give del x, del y, del z. Okay, now if you consider any point in D, yeah, consider any point in D. So let's say those points we define as A, B, C, where this point is in D. So if we evaluate those points, F at those points, F, A, B, C, so we call this as a density, the value of the density, per unit volume. Yeah, the volume of the value of density per unit volume at point A, B, C. Now, to evaluate those integrals, we evaluate the volume of region D is defined as, we integrate 3 times f x, y, z dv. Okay, let's see example. Let's say we have we want to evaluate the density for f x, y, z is given as x, y, z. So the function is given as x, y, z, where the region D is a cube with boundary x equal to 2, y equal to 2, z equal to 2 in the first octant. Okay, so basically, if you plot or sketch those region, so you have x equal to 2, y equal to 2, and z equal to 2. So we have this cube. So we have that cube. So this is our region D. All this. Okay, that's our region D. Now to evaluate those volume integral, or to evaluate the density, alright. So we need to evaluate those triple integrals. So we have volume or to evaluate the integral. So we have f x y z dz dv. Sorry. So this is over d. That gives, we integrate x from, you see, x from 0 to 2. Okay, x from 0 to 2, because this is just a cube, so it's easy to find to determine the limit of integration. S equal to 2, 0 to 2, y, can see z, y from 0 to 2, y from 0 to 2, and z from 0 to 2. Okay, z from 0 to 2, 0 to 2. And the function is given here, x, y, z. So just integrate x, y, z over dz, dy, dx. Okay, so it's not difficulty because the function is simple, and the limit of integration also simple. So you can evaluate this. This you have x, y, z squared over 2, evaluate from 0 to 2, dy, dx. Okay, then you can proceed this. That give you the answer is 8. Okay, remember that we evaluate the volume integral. Triple integral, we have a function of x, y, z, and with respect to each of those variables. Give you another example. Okay, let's consider same function f x y z is x y z, and v is given as the region D is given as z equal to 4 minus x squared minus y cut by z equal to 2y. Okay, so how can we sketch this? I think you know this, right? So let's try that. Probably we need, if you substitute into that, because it's cut, so we must have the intersection between those plane with that surface. Okay, if we substitute there, so that give you y equal to 4 minus x squared minus y, because here is where we have y equal to z here. You substitute into there, so you have y equal to 4 minus x squared minus y. That gives you 2y equal to 4 minus x squared. So y is 2 minus half x squared. I think you can recognize this. Okay, this is on xy plane. Now look at z. So let's see those things. Okay, so just as usual, we consider each of the axes. So for x-axis, yz is 0. Look at those. X-axis, yz is 0. So you have x squared equal to 4, right? So x is plus minus 2. So we have plus minus 2. We have 2 here, 2, and minus 2 over there. So I should put here in the first octant. Okay, because I don't want to consider the negative parts. So x from 2 to minus 2, so the negative part we remove, because we just need to consider in the first octant only. And for the z-axis, xy is 0. If you look at the function given here, xy is 0, so z equal to 4. So somewhere here z equal to 4. Okay. On y-axis, xy is 0. Xz is 0. So y equal to 4. So y equal to 4, probably somewhere there. That. Okay. Then we consider on all axes. Now we consider the plane. For the xy plane, z is 0. So look at that. Z is 0 for the xy plane. Z is 0. So we have y equal to 4 minus x squared on the xy plane. So y equal to 4 minus x squared. So we have that, right? Parabola. Oh. That. On y xz, y is 0. So look at the surface given. Xy, so xz, y is 0. So we have z equal to 4 minus x squared. Alright, z equal to 4 minus x squared. Okay, so that give us that. Okay, and for yz plane, x is 0. Look at those, x is 0. So we have z equal to 4 minus y. That's a negative slope, and cross axis is minus 4, 4. So we have a straight line over there. So we just have a straight line. Okay, so this is the surface for z4 minus x squared minus y. But it's given here, it is cut by z equal to y. Z equal to y is what? Z equal to y is this line, right? That line. This is z equal to y. Alright. So we have a surface, we have a plane z equal to y, cuts those surface. So we have, it look like that, right? Okay. Now this is our region. This is our region, our surface, and this is our volume. Okay. Now we identify those our volume. Now, if we project those, because in order to evaluate those things, we need triple integral. This is for x, this is for y, this is for z. Okay, z, if you look at this z from y, that plane onto that surface, the surface is given, this surface is, that surface is z equal to 4 minus x squared minus y. So that surface. Okay, so z from y to 4 minus x squared minus y. Our function is x, y, z, dz, dy, dx. What about x and y here? X and y here, this I would say, if I can call it region R, where the region R is the region where the surface is projected on the xy plane. So if you look at this surface, look at from z positive, so that surface is projected on the xy plane. So you have this point projected down there, this projected down there. So those lines are projected down there. So we have those lines, and this line is given as, we have solved this, y equal to 2 minus half x squared. So this line there is y2 minus half x squared. Now you can determine the limit for y from y equal to 0, which is x-axis, until that curve. So that curve is given by this. So y equal to 0 to 2 minus half x squared. Okay, so this is down here, this is our region R, this region R. And for x is from 0 to 2. X from 0 to 2. Now you can evaluate this. Okay, I don't have to work out in detail this thing. I believe you can do it. I just leave it to you. Okay, and this is the solution is 32 over 19. Okay, please check those calculation. I hope you can get the same result with that. Okay, let's consider another example. Just talk on the example. I just give an example in this video. Give you another example. Let's say we want to evaluate the volumes. To evaluate volume, bounded by z equal to x squared plus 3y squared and z equal to 8 minus x squared minus y. So if I can call this is as equation 1, this is as a equation 2. So you can see from here, basically this is like open cup. It's like this, right? And the other one, this is like this, the closed cup. So we have a volume over there. So if you want to sketch this region, is not easy, I guess. You can, but it's not easy. Okay, so for this we have an open cup, ellipsoid. All right, so you have something like so let me try this. So we have x there. So we have it should look like this, right? So we have those. Okay, all right. You can determine, of course, what the point here, what is the point there, what is the point there, what is the point there. You can find out those things. Just look at those. What happened when on x-axis, what happened on y-axis, and so on. And for this, we know this is the closed cup, so it should look like z from this one should touch 0. Should start, because we don't have any constant for z here, so it should give somewhere here. So it should be like that. Okay, and for this you have a closed cup. So this cup, so we have those is closed with that, because this is 8 given by the 8. Okay, so if we project this surface, you project the surface on xy plane, so what we have is something like that. Those there. So it's something like on xy plane, and this line is given as you just solve those two equations. You have x squared plus 2y squared equal to 4. Not difficult to find this, you just need to solve these two equations. Alright, so you can see this is z equal to that, so we have x squared plus 3y squared, this is equal to 8 minus x squared minus y. So rearrange those things, so we have 2x squared plus 4y. I think I'm missing something here. Here should be y squared. Okay, so here should be y squared. So this is 4y squared equal to 8. So x squared plus 2y squared, that equal to 4. So that we have this thing. Okay, so if you write in terms of y, so we have y is equal to, of course you have plus minus, square root. Alright, so we have 4 minus x squared, 4 minus x squared over 2. Right. So positive part is this, right? This line that gives y equal to positive of those 4 minus x squared over 2. The negative part is this one, y equal to negative 4 minus x squared over 2. Now you can evaluate. And one more thing I want to stress in this example, we want to evaluate the volume, not the density but the volume. So the volume, if you use triple integral, we have a function f here, dv over region D. So this function is equal to 1. That will give you a value. If different than 1, then it gives you density. If equal to 1, it gives you volume. So now for those integrals, so we need to evaluate those. Okay, f dv, that give us integral over region D. Our f is 1, dv is dz, dx, dy, dx. Okay, so now we need to determine the limit of those integral, right? For z from, this is the open cup, this is the closed cup, so this should be the lower limit. So we have z from x squared plus 3y squared to 8 minus x squared minus y squared. Okay, and for y is from there and there, so negative to the positive. So y from negative of 4 minus x squared over 2, okay, to the positive 4 minus x squared over 2. Alright, and x from, you can determine from there. On x-axis y is 0, so x is plus minus 2. So here is 2, here is negative 2. Alright, so x from minus 2 to 2. dz, dy, dx. So you need to evaluate this. Alright, so it's not difficult for you. I think I can do this halfway again. So this is y 4 minus x squared over 2 at 4 minus x squared over 2. This is negative, that one is positive. So z, where z from that x squared plus 3y squared to 8 minus x squared minus y squared dy dx. Okay, so if you evaluate this, so what we have, that y is negative 4 minus x squared over 2 4 minus x squared over 2. That one is, so we have 8 minus x squared minus y squared minus x squared plus 3y squared dy dx. So what do we have there? That give you 8 minus 2x squared plus is it minus minus 4y squared. Okay, now evaluate that with respect to y. So what we have, x from minus 2 to 2, differentiate that with respect to y. So we have 8y minus 2x squared y minus 4 over 3y cubed, where y from negative of those 4 minus x squared over 2 to 4 minus x squared over 2 dx. Okay, so if you proceed this, you're going to have x from minus 2 to 2. Of course, you need a couple of steps here, because we need to evaluate. You need to evaluate this thing, substitute there, and then do some algebra. Then you can have this. So you will end up with a kind integrand of the form 4 minus x squared over 3 over 2 dx. Now you need to evaluate this integral. It's not easy, right? You have 4 minus x squared. You cannot use normal substitution. Okay, so how to do? I show you. Yeah, from that function, from that integrand. So how do we do that? I can factor out. I write it here. Minus 2 to 2. 4 minus x squared 3 over 2 dx. Okay, so that x from minus 2 to 2, yeah, I can factor out those. So what we have, 4 3 over 2, what left is 1. Okay, inside there we have x over 2 squared, because we have factored out 4. So we have 2 squared, we got 4. 2 squared over 4, so you can have those things. Alright, so this is 3 over 2 dx. So if you can see from here what we have. We have 1 minus sine squared or cos squared. You can use 1 minus sine squared. This is equal to cos squared theta. This is identity. That. Okay, we try to apply this. Now if we substitute, let x over 2 equal to cos, right? You can take cos, you can take sine if you want. I think because I wanted 1 minus sine, so I can put sine here. You might, why sine? Why not cos? You can, of course. X over 2 cos theta. If you substitute this, then you have 1 minus cos squared, then you can take sine. If you use this 1 minus sine squared, then you can use cos squared. So either one. So okay, so what we have now, that will give you, for sec 2 over 3, you just simplify all those things. From minus 2 to 2, here you have 8, 1 minus x over 2 squared 3 over 2 dx. Please check those algebra. With those substitution, so we have x is equal to 2 sine squared right? And theta from minus pi over 2 to pi over 2. Why is this? Because you look at our diagram is from here to there, so half of a circle. All right. Then dx is 2 cos theta d theta. Then you substitute into there, you got 4, just multiply that, 8 to 32, sec 2 over 3. Okay, integrate our theta now from minus pi over 2 to pi over 2. And inside there we have 1 minus sine squared theta, 3 over 2. Dx is 2 cos theta d theta. And this give you cos squared. Okay. And so what else we have? Half. So we have x4 here. This is x3, cancel. X squared, cos squared. We have sec 2 here to cancel out. So we have cos cube. We have another cos here. So altogether we have, and multiply that over there. So you got 64 square root 2 over 3. Integrate minus pi over 2 to pi over 2. So you got cos 4 theta d theta. Yeah. To evaluate this, you need to write that as cos 2 theta cos 2 theta. Okay. And cos 2 theta, that is cos 2 theta plus 1 over 2. So you have those, so just square. Now you can evaluate this. Okay, I think I don't have to finish this. So you just proceed. Then you get the answer is what is it? I don't have the answer. I don't have the answer. So 8 sec 2 pi. Okay. So I think I stop here for this video, and I have one more subchapter to discuss, which is a theorem, a Gauss theorem or divergence theorem. So those with the divergence theorem will be our last lecture for this semester. All right. Thank you.